Welcome to the final video. It's going to be short, hopefully. We'll see. All right, so this last video, we're going to look at limits at infinity. So let's say I give you a function, and this function looks something kind of like this. Y is equal to 1 over x plus 2. So the whole idea of limits is, as x approaches a number, what does y approach? Well, limits at infinity is going to say, as x approaches infinity, as x goes zooming to the right, what does the y value approach? Well, we can go as far to the right as we want. The y value is approaching 2. So we'd say the limit of this function as x approaches infinity is 2. All right. And similarly, if I looked at like this function, e raised to the negative x minus 3, I'll say minus 4, right? This is an exponential function with a horizontal reflection. And as we go really far to the right, as x approaches infinity, the y value, you can see the y value. All right, this one goes so fast that Desmos is just like, yeah, all right, it's getting really close to 4. It's basically 4. All right, so that's what we're talking about here. Limits at infinity is as x goes really far to the right. Here we go. All right, so let's evaluate some of these limits. Example 6. Evaluate. Part A is the limit as x goes to infinity of 1 divided by x squared plus 1. You can't see anything, but now you can. All right. What happens here? How do we do this without a graph? How do we do this without a graph? Well, we're just going to kind of look at some things. So as x gets really big, as x goes to infinity, x gets large. It's going to the gym every day. It's working out. So if x gets large, x squared gets really large, right? If you square a big number, it's an even bigger number. So the whole denominator, x squared plus 1, also gets large. This is a full body workout, okay? So if our denominator, right, this is our denominator. If our denominator gets infinitely big, what's happening? We have 1 divided by something that's getting bigger and bigger and bigger. 1 divided by something that goes off to infinity. The limit is 0. Okay? Because we have 1 divided by something really big. 1 divided by really big. Again, some more high quality, very specific math right here. Like 1 divided by 1,000,000, 1 divided by 10 billion. You're going to get really, really close to 0. And we can see this graphically as well. Let's look at this function. All right. 1 divided by x squared plus 1. As x goes off to the right, look at those y values. Y values are getting closer and closer to 0. All right, and that's just kind of what's going on here. Do another one. Part B. No blue. Part B. The limit as x goes to infinity of 6x plus 1 divided by 2x plus 1. Now let's change one of these to a minus. All right, so a lot of problems, if they're like this, you can just use the same logic and it all works out. This one's a little bit more confusing because this one is not going to be this case, 1 divided by a really big number. Because what's happening on this problem is as x gets big, well, this gets really big. And that gets big too. So we got really big over really big. And that, I don't know what really big over really big is. So we're going to do a little trick. All right. Let's look at the same thing, but let's rearrange things a little bit. 6x plus 1 over 2x minus 3 times 1 over x divided by 1 over x. We're multiplying by the same thing over itself. Right? This right here is 1, so we're not changing anything because this cancels to 1 right here. But we're just rewriting it to see what happens. And I'll show you why we multiplied by 1 over x in a second. Let's distribute. All right, what is 6x times 1 over x? 6x times 1 over x, the x's cancel. We're just left with 6. 1 times 1 over x is 1 over x. And now in the denominator, 2x times 1 over x is just 2. Minus 3 times 1 over x is 3 over x. Now look what's happening. As x gets really, really big, 1 over x gets really small. We're dividing by a really big number, just like in part A. So as x gets really, really big, this goes off to 0. As x gets really, really big, this goes off to 0 as well. So as x gets really, really big, what do we have? We have the limit as x approaches infinity of just 6 plus 0 over 2 plus 0. There's no x's anymore. We can plug in x. There's nowhere for x to go. So this is just 6 over 2, which is 3. All right. So that's another way of approaching this. And if it were like 6x squared over 2x squared, then we divide by 1 over x squared over 1 over x squared, okay? We just multiply by this thing. We want to get rid of the highest x term over here. All right, so that's kind of what's going on here. We want to eliminate highest x. Let's do one more. Show you something else that can happen here. And then if you have other questions on this, you can always ask. Part C. What is the limit as x approaches infinity of 3 times e to the negative x plus 1 over 2 times e to the negative x plus 2. And there's a couple of ways of approaching this. One of the ways is to remember what negative exponents mean. Remember, negative exponents, so e to the negative x, means reciprocal. This is 1 over e to the x. So let's just rewrite this in a complex fraction. It'll look a little bad for a bit, but it'll get better. This first term becomes 3 divided by e to the x. The denominator becomes 2 divided by e to the x. Now, right, as x gets really big, e to the x, e, 2.718, etc., Euler's number, to a really, really big number, also gets really, really big. So 3 divided by a really, really big number goes to 0, just like in part A. And same with the other one, right? So this guy up here goes to 0. This guy over here goes to 0. What are we left with? We're left with the limit as x goes to infinity of just plus 1 divided by plus 2. There's no more x's. So the limit is just going to equal the function value. The limit approaches 1/2. And again, healthy skepticism is A-okay. Let's check it out. Let's see what we have here. 3 times e raised to the negative x plus 1 divided by 2 times e raised to the negative x plus 2. As x gets really, really big, look at those y values. 0.542, 0.502, 0.5. It's getting really close to 1/2. All right. So that's kind of what we can do for these limits at infinity situations. And we'll talk more about these later on in the class as well. good luck. Let me know if you have any questions. And there's also 1.5 this week, but 1.5 will be quite short. Okay. I think most people think 1.5 is much easier than 1.4, but let me know if that's not true for you. I'm always curious to know how students view these different sections, like what your guys' experiences are. And it's a little harder to gauge in an online class because as I'm talking, I can't see your face. I can't see you go. So it's a little harder to know, but yeah, feel free to always let me know this sort of stuff. It's always helpful, I think. Anyway, have a great week. Good luck on these homework problems.